We introduce a new word here, multiplicity. And so if we look at the two graphs that are in your notes, this first one, we say it has a multiplicity of 2. The 0 of 1, this is on page 44. That one has a 0 of multiplicity 2. Because if you wrote it out completely, you would have f of x equals x minus 1. If you were factoring, you might get x minus 1 times x minus 1. And if you were finding your x-intercepts, you would get x equals 1 twice. And when you get something twice, we'll say that it has a multiplicity of 2. In the second one, for g of x, you have x minus 1 happening 3 times. So you would get x equals 1. You would get the same 0 3 times, and we would say that it has a multiplicity of 3. So a little note that we can add at the bottom or on the side of our page here. What did you notice when we had an even multiplicity? The graph bounces. At the x-intercept. And what did we notice? Well, I guess when it's odd, there's two different things that can happen. Right? The odd multiplicity, if it was 1, it just went straight through, right? If it was any other bigger number, like 3, 5, 7, then what happened at the graph? It bends. It bends so much that it actually gets flat for a second. Okay? What does that remind you of? What graph does that remind you of the bend? An x to the third graph. And if you think an x to the third graph is really just x minus 0 3 times, it has a multiplicity of 3. And you have a bend at 0. Ooh, that's pretty cool. And so let's look at our first example here. F of x is x plus 1 to the 4 times by x minus 2. So the first thing you have to decipher is what kind of graph is it? Is it a cubic? Is it a quartic? Is it a quintic? What's the highest degree? And so the way that you can think of it is this x to the plus 1 to the 4 is really going to give you an x to the 4 in that. And this 1 that is to the 1 would give you another x, and putting those both together, that's going to get you an x to the 5 graph. It's going to be a positive x to the 5 graph, so our end behavior is going to act like a positive line. When you go to graph it, since it's already factored, you know that you will have one x-intercept at -1, the other one at 2. If you plug in 0 for x, you're going to get -2 for your y-intercept. So our graph has to start down here. When it gets to our 0 of -1, since it's an even multiplicity, it's going to bounce. And at 2, it's going to go straight through. And so when you draw your curve, you just try to draw your curve as smoothly as you can. So at -2, I could have started going back up already, but it just didn't feel right the way that the curve was going. It felt like I needed to go down a little bit further. But it wouldn't be wrong if you curved it right up right away. It would be wrong. They won't like straight line graphs. That's really bad because that's not even close to going through. That would be not good because it's not a smooth curve. So when you're going through your graph, starting down here, I knew I had to bounce. Wow, that would be a bad bounce. Let's try that again. So I knew I had to bounce off that one, and then I have to come back up. So anything like that would be fine. Of course, when you study calculus next year, you're going to find out how you can use calculus to find these minimum points. For our second graph, this is an x to the what graph? An x to the 4 graph. Positive or negative?
Negative.
Negative. So it's going down. If we plug in our x-intercepts, we have 1 at -1. One at 3. And when x is 0, plug in 0 for x, you will get positive 3 as your y-intercept. So our graph needs to start down here. It needs to end down there as well. What's going to happen at -1? Odd multiplicity, it's going to bend. And at 3, it's going to go straight through. Yeah.
Why did the other one change to negative 1? I mean to 1, since it says negative outside the bracket?
Well, I'm just looking out between my factors here. What would make this 0? X equals -1 would make that 0. So that's why it's an x-intercept, or why we sometimes call it a 0. That negative out in front doesn't affect what makes this part 0. So there's our final graph. So the ones to practice are 9, 10, 11, and 12.